Hi Labmentix. Let's get started with our first project, that is Amazon Prime EDA. So what does this EDA means? So EDA refers to the Exploratory Data Analysis. So this is a very important step during the data analysis. When they have given a large set of data, we have to make sure we have a proper data set. The data set has to be properly handled, and from that data sets, what are the insights that we are going to take it. So from that, what are the business impacts that is going to be happen, what are the positive impacts we have, the negative impacts we have. So everything will be considered. We will be also seeing the how we are going to make the visualizations using the current given data sets. So today we are going to make the EDA, that is exploratory data analysis, by analyzing the various attributes that are present in the given data set. For that we will be doing the data visualizations, and we will be deciding what are the insights that we can take from the given data set. So the Amazon Prime EDA. So the project summary. The project summary says that we are going to do the exploratory data analysis as I told in the earlier. So we will be having mainly two data sets, that is titles.csv and credits.csv. In the further steps, we will be seeing what are the attributes that are present in this particular data sets. The main objective of this project is to analyze the Amazon Prime video dataset, to understand the patterns and what are the trends and what are the relationships within the data. Or also the goal is to extract the meaningful insights that can support the data driven decision making. So for that, we will be making a data preparation. The analysis begins with the data understanding and also cleaning. So for whatever the project that we start, especially in a data science or a data analytics or ML, we have to first be thorough with the what is our data set consist of. What are the changes I need to make before moving further? So to make the proper valuable insights, these are necessary steps. So and also what this involves. So checking for the duplicate values, handling of the duplicate values, checking for the missing values, handling of the missing values, and also correcting of the data types. And also we will be merging these two data sets for the multivariate analysis. When I said we will be doing univariate, bivariate and multivariate analysis of the EDA process, it generally involves univariate means when we choose only one particular variable for our analysis, that will be univariate. If we choose two variables, that is bivariate. If it is more than two, then it is multivariate. Simple. So exploratory data analysis, this is what univariate, bivariate and multivariate. And also we will be analyzing the contributor and the regional analysis. So the project also analyzes actors and directors to identify the frequently appearing contributors. Additionally, production country analysis helps understand global content distribution trends also. And this analysis reveals key insights such as dominant genres we have, content growth trends, and factors affecting rating for popularity. And these insights can also improve content strategy, user engagement, and business decisions. So the overall conclusion says that this project helps us to convert this raw data into actionable insights and provide a strong foundation for further machine learning and predictive modeling. So this is my GitHub link. The problem statement says that we know that Amazon Prime is a fastest streaming platform nowadays, and also we have to make sure that should keep continuing, and also we have to make sure that we are satisfying the customer needs by providing the required movies and required shows in the Amazon Prime. For that we need to analyze the data, like what type of content that is preferred by our customers, what type of TV shows they are preferred, are the people are really enjoying what they are seeing. So for that we require this project. So content preferences, audience preferences has become crucial, and Amazon Prime Video dataset contains detailed information about all the movies and TV shows with the important attributes. However, the raw data does not directly provide insights into which factors influence content success. If you just see the dataset, nothing's gonna work. But if we analyze the given data set, then we will be able to understand what's the main uh, insights that we can draw. So audience engagement, platform growth, therefore there's a need to systematically analyze this video to uncover hidden patterns, relationships and trends as well. So the main business objectives here we have understanding trends in content production over the years, analyzing the relationship between the ratings, odds, popularity, evaluating impact of actors and directors on content success, understanding regional distribution of content across countries, and insights gained with analysis within help like making informed decisions about the content acquisitions and production, improving recommendation system, enhancing user satisfaction, retention, optimizing overall platform growth and performance. Based on the ratings, I may improve my recommendation system. So these are all very necessary for the business. Okay. So before analyzing data or before gaining a valuable insights, we have to first understand the data. What's our data set consist of? So if you are able to do that, then we can easily draw the valuable and a meaningful insights. So first, in order to know our data, we know that Python provides a very helpful libraries like Pandas, NumPy for the knowing our data, especially Pandas for the data processing and NumPy for the numerical computations, and Matplotlib and Seaborn, these two mainly use it for the data visualizations where we can easily draw our data insights by looking at the graphs. So in this Pandas and NumPy, so Pandas and NumPy helps us very they are very helpful while understanding our data. So for example, in order to understand our data, we require data. So we need to load our data into our programs. So for that, we require a pandas library. So we will be using the syntax of pd.readcsv as they are comma separated values. Just we will be getting this titles data set, that is title is equal to pd.readcsv, and we are going to put r here because it has to read the absolute path. If you don't want to put r, just put the double slashes over here. It will help us to read the data set from there. So first we have to upload the data sets over here, and then we are going to just read it, so using the pandas library, and successfully our data set has been loaded, as you can see the successful message. So for the any data set, first we need to know what are the attributes and all we have, but before that we should also know what kind of the value, how the values are being stored. So we can just see, or we can just get access into the few columns of the starting rows. So we can use the head function. So we'll be having head function for title and credits, head function for the credits as well. So you can see that you are getting two different data sets of having the 5 values initially, and you can also see that there are NaN values at the beginning itself. So we have ID, title, type, description, release year, age certification, runtime, genres, production country, seasons, IMDb and IMDb scores and all so on. And even in our credit data set, we have person ID, ID name, character and a role. So data set rows and a column count. So first we need to understand, so how much big is my data? The more big the data, the better insights we can draw. But at the same time, we have to make sure our data set is free from the duplicate values and free from the null values. So data set rows, in order to do this, we can just use a shape method which will return both row and the column from both the data set. So our title data set consists of totally 9,871 rows and column is 15. Whereas our credits consist of rows is around 1,24,235 and columns as 5. So dataset information. Why this dataset information is required? Whenever we trying to process our data, we must be knowing of what is a column name, and also what is the data type of that column, and also what are the total of non-null count. Everything should be calculated. And so here, so we are using info method. Title.info, we can see that it is a pandas code.data frame. That means whatever the value we have, it's a two-dimensional which consists of both rows and columns. And also we can see that each column has its own data type. That ID is an object, title is an object, description is object, and IMDb ID is a float, and popularity of float. Object is nothing but a string values. And also we can see that how many data types, float is of how many types, that is 5, int is of 2, and object is of 8, and memory usage it is taking 1.1 plus MB, and similarly it's for the credits dot info as well. So while knowing our data, I need to check for the duplicate values as well. So I'm checking the duplicate values here. In order to check the duplicate values, I use the duplicated.sum method, where it will return the number of duplicates in the particular data set. So here we are using data set and along with the duplicate dot sum. So 3 and 56. Then missing or null values. Is there any missing or null values? Yes, we do have so many missing values. So is null dot sum. So here we are IMDb as this much, null values, core as this. And even in the credits data set, we have to make sure that we are checking it. Then visualizing the missing count. So how much the values has been missed. So for that we will be using a heat map visualization from the Seaborn library. So as you can see here, the white marks over here, they represents a null value. If you can properly observe over here, so this has been applied on our title data set. So in the title data set, description is 119 and age certification is 6487. So description has quite less white marks, whereas age certification has more. So wherever there is a white mark, it represents a null value. Similarly for the credits data set, here we can see that everything is 0, 0, 0, but for one value we have around more than 16,000. So now the question is, what did you know about your data set? So I came to know that I have around 14 attributes and here around 4. So this exploration, it is observed that data set includes both numerical as well as the categorical variables, and some columns contain the missing values which need to be handled appropriately during the data cleaning. So the presence of duplicate values is also checked to ensure data consistency. Then understanding your variables. So we will be checking for the column names. So we can just use data frame dot column values here, and then the columns of the credits data set as well. So we are checking the columns of this credit data set as well. So index, person ID, name, character, these are the columns of the credits data set. And we do have this data type of object, and here also D type object as well. Next is data set describe. So we will be using this title dot describes to know the number of rows where the count will return, and what is the mean value of this particular column, what is the standard deviation, minimum, 25th percentile, 50th, 75th, and maximum value. And also we can apply this generally describe method is applied on the numerical columns, but we can also apply on the object column. So where it says title dot describe of include is equals to object, so we need to mention include is equal to object, and it will return the values here. So count, unique, and top, and frequency and all. So here it will return the number of rows it has, and what are the unique values it has been having, and which is the topmost value. So we can see that on the type of the show, type consists of mainly two values, that is show or the movie. So top, in the top I have this movie. So movie, here it is giving us one kind of information that the type of the shows that is present in the Amazon EDA is movie. And data set description for the credits data set. So for the numerical values, the applying credits value, similarly for the applying credits for this object as well. Then is variable description. So we have returned what are the categorical variables that are present in the titles data set, which are all the numerical variables present, and which are same thing goes for the credit data set as well. So what are our key observation? The data set consists a mix of categorical and numerical variables, mixing it suitable for comprehensive analysis. So several columns such as age, certification, seasons, IMDb score and TMDB score contain missing values and require pre-processing. The credits data set has significantly more rows than the title data set due to multiple contributors per title. So the ID column acts as a key to merge both the data set. So this data set is rich in information and provides multiple dimensions for the analysis, including content type, ratings, contributors and regional distributions. Proper handling of missing values and data types will be essential for the accurate analysis. So check unique values for each variable. So let us see which are all the unique values for each variable. So we will be applying the for loop here for each column in this title dot column. So how many unique values are there? ID as this much, title as this much, type. So this is excluding our duplicate values. Unique values for our credit data set. Next step is data wrangling. Data wrangling is the process of cleaning, structuring and even enriching the raw and the complex data into a usable format for analysis, machine learning or even the visualization. So removing the duplicates. So in the knowing our data, we came to know that there were a lot of duplicate values. So we have to remove the duplicate values for the proper insights and analysis. So what we will be doing is, so we will be taking title dot drop duplicates of in place is equals to true. So why we are placing this in place is equals to true is that this in place is equals to true, using in place is equals to true. Why we are using is we have to make the changes in our original data set only, so there is no need to create one more data set. And once we check for the duplicate values again, so it is title dot duplicated dot sum method, so it will be giving us the answer as 0. That means all the duplicates have been dropped. Our data set is one step ready for the analysis. And then title dot is null dot sum, so it's a method which is used to know the sum of the null values that are present over here, so like description and age, certification and all. So it will return the total null values we have over here. So then missing values analysis. So if we properly see in the title data set, we have age certification as this much, 6484, missing values description as 119, seasons as 8511, IMDb as 667, missing values, IMDb scores and IMDb odds as 1000 missing values, over 1000 missing values, and TMDB popularity and TMDB score also as containing missing values through comparatively fewer. So key insight is missing values are concentrated in a specific columns rather than being randomly distributed. So now we are handling the missing values here. So for the description of the movies or the TV shows, so we are filling those values with no description available. And for the age certification, we are writing it as unknown, that we don't know the ages. And for the title, for the for drop, see, we am dropping the seasons for the movies. Of course movies won't be having any season, so it is so expected that the data set will be having the null values on the number of seasons. So I'm just dropping them off and fill ratings with the median. So there are a lot of ways where we can handle our missing values. One, we can just totally drop it off, or we can fill the value like unknown, no description available, such like that. And we can, for the numerical values, we may sometimes take the median of that particular column, or else we can go with the mode of that. So for the IMDb score, I am going with median. For TMDB score also I'm going with the median, and IMDb odds I'm filling it with 0, and popularity also I'm filling with that with a 0. So once we check for the isNA.sum, so nothing's as this, everything as 0, and IMDb ID is of course 6687 because it is the column for the identifier. So but still we are going to just like fill them with as unknown here. The and we do have this. Next we are analyzing it for the credit data set, when we can observe here the character as this 16277, because sometimes the here this data set consists of even the director as well. So director won't be having any actor, so of course it is also expected one. And then, so data wrangling, manipulation and insight. So what are the manipulation that we did for our null values? That is been present over here. Fill missing values with placeholder, age certification with unknown. So whatever we have done here, so it's a brief description of what is. And then data cleaning and data merging will be done. Then data visualization, so storytelling and experimenting with charts, understand the relationship between the variables. So actually the data visualization is a very important tool for us to gain the very good insights. So as we discussed earlier, so that EDA will be consisting of univariate, bivariate and multivariate variable analysis. So we will be seeing all this in the form of the data visualizations. So first I have taken this count plot. So we know that our title data set mainly as two type of categorical values. One is shows and movies. So here I am using this count plot to check how many movies and how many TV shows has been present in our data set. So by the graph we can easily see that the movies are more streamed but the TV shows are very less streamed. So why did I pick this chart? Means because it is a count plot is a very good data visualization tool in order to do check the comparison or make the comparison between the categorical variables. So here we have mainly two things, show and movies. So if the movies is being more preferred, then we can push movies into Amazon Prime. So what is the insights we got from this chart? So I can say that the movies has been more watched and more pushed into the Amazon Prime, whereas less is show. So the positive impact is here. The larger collection of movies can attract the people who likes a lot of movies. At the same time, when we push the TV shows less, it will reduce the user engagement with the Amazon Prime, because the movies is a one-time show. If you watch it, the person is not going to watch it again. But when it comes to the TV shows, they are the ones who will make us a binge watching. Like it will they will make us to watch like seasons continuously. So this will be having icon connect with the Amazon Prime. So higher retention, this imbalance might lead to missed opportunities in capturing the audiences who prefer episodic content. So therefore the platform can consider increasing TV show content to improve user engagement and retention. Next is chart 2. So this is also univariate, as you can see. That means I'm using only single variable. So here also I was using only content type. And then in the distribution of content release, so we can see that the movies that has been added over like 1920, 1940, 1960. So the newer the movies, they have been adding up. So that means the latest release movies are being added more in the Amazon Prime. So the why did we use this? Histogram is a very good tool for the distribution of numerical variables. It helps to analyze how content production is spread across different years and identify trends in content release over time. So the insights we can gain here from is that the most of the content is concentrated after the years 2000, with a noticeable peak in the last 2 decades. So the gain insights is that of course the people who are new generation people will be preferring this the movies within this range. But the negative impact also, that the people who are like old age people, they tend to prefer more of the movies which are released in this area. So it's like creating a gap. So over dependence on recent content may reduce content diversity, and also limited older content may reduce appeal for users who prefer classic or vintage movies as well. And chart 3 is also univariate, where I'm using distribution of IMDb scores actually. So IMDb scores and their frequency. So here the histogram is used to analyze distribution of numerical values. IMDb score is a key metric that reflects audience ratings, and this chart helps in understanding how content is rated over on the platform. So we can see that content is more congested near like 5 to 7 or something like this, but whereas 6 to 7 is little bit higher over here. So we can say that the we know that IMDb scores, right? So International Movie Database scores. So here we are able to observe that whatever the movies that is been uploaded in the OTT as a minimum ratings, it's not that too bad. But at the same time, we have this negative impact that highly rated titles may reduce platform's ability to attract premium audience. That we can see that very less movies have got the very good ratings between 8 to 10, so which is uh, negative business impact. Then is chart 4. So in this we will be identifying the top genres that has been present in the Amazon Primes. So that is, we will be extracting the genres and we will be adding that to with the we will be extracting top 10 genres, and that will be marked with the bar chart. We can see that drama has the higher priority, then comedy, thriller, action and romance that goes on. So this helps us to compare the different categories in this scene. So it helps us to identify the most common genres available in the platform, so making it easier to understand content distribution across categories. So the chart shows the certain genres like drama, comedy and action are more dominant compared to others. So this indicate that the platform focuses more on these popular genres, while other have a less representation. So the positive impact is that we can just focus on drama, comedy, so which will attract more audiences than the genres which are below the bar chart. And next is chart 5 says what is the relationship between IMDb score and IMDb popularity. What we are trying to do is here whether all the popular movies have the higher ratings or all the higher rating movie are more popular. So it is a bivariate analysis. So we can see that it's not that consistent. So the scatter plot is used to analyze the relationship between two numerical variables, and this chart helps in understanding whether higher rated content is also more popular. And this shows the scatter distribution, indicating that there is no strong linear relationship between IMDb scores and TMDb popularity. So this gives us positive impact that the modularly rated content can still become popular, indicating opportunity for wider audience reach. Popularity is influenced by factors such as marketing trends and stock as not just quality. There is also a negative impact as I mentioned, high quality content may not always gain visibility, leading to the underutilization of the good content. And chart 6. Here it is, we are checking for top 20 actors by the number of appearance. So we can see the George Hayes, Ray Rogers or this top 2. Best Flowers is a top 3. So a bar chart is used to compare the categorical data as we know, and this chart helps us to identify the cost frequently appearing actors in the data set. So providing insights into contributor involvement. So what is or are the insights found from the chart? So the chart shows that a few actors appears in the large number of titles, while most actors have fewer appearances. So this indicates that certain actors are highly active, frequently featured on the platform. So then we have this business impact. This insights helps in understanding the influence of actors on content production. Positive impact and the negative impact is also there. So frequently appearing actors may attract loyal audience and increase viewership, but this may also like a negative impact for other actors, like it will be like less chance for the newer actors. And chart 7, it's a bivariate average IMDb by the top directors. So based on top directors we are calculating the IMDb scores over here. So we will be using the bar chart for this, of course. So categorical entities helps to identify directors who consistently produce high quality content based on average IMDb ratings. So the chart shows that certain directors have consistently higher average IMDb scores compared to others, and this indicates that some directors are more successful in producing high quality content. So business impact is helps in selecting directors who consistently produce this high rated content, so improves content quality and audience satisfaction. Negative impact is over reliance on few directors may limit diversity in the storytelling, similar to this actor as well. Next is I'm identifying this is a bivariate. So genres versus IMDb scores. We are identifying this. So we will be checking the genres and what is their IMDb scores, and we can see this line is our median, which is Q2, this is Q1, this is Q3, and this is minimum value and this is maximum value, and these which are round or they are the outliers. So this box plot is mainly used to compare the distribution of IMDb scores across the different genres. So it helps in understanding how ratings vary between genres and identify trends, spreads and outliers. So insights, some genres consistently have higher median IMDb scores, certain genres have wider spread, indicating consistent performance. Presence of outliers suggests that some movies perform exponentially, especially well or poor with each genre. So positive impact is helps to identify high performing genre for content production, assisting targeted recommendation based on user preference, enables better content strategy planning. Negative is overproduction in popular genres may lead to the saturation, less popular genres may be underutilized despite nice demand. Next, we are checking the relationship whether movies have a better longer movies have a better rating. I don't think so. Let's see. So the scatter plot is used to analyze relationship between runtime and IMDb score. It helps us to identifying whether longer or shorter content tends to receive better ratings. So insights, the scatter plot shows that there is no strong linear relationship between runtime and IMDb scores. This suggests so both short and long content can achieve high ratings runtime. So there is no such relation. So content creation of flexibility in choosing runtime focus on can be placed more on content quality rather than duration. So it shows that quantity doesn't matter, quality matters. So chart 10 is also we are doing runtime distribution using the box plot. We are using univariate. So runtime distribution of content, runtime minutes. So as I told, this is our median value, Q1, Q2, Q3. This is minimum value, maximum value, and these are the outliers. So why did you pick this chart? Because the box plot is a common visualization tool that is mainly used for our numerical data and detect the outliers. So helps us to know how the values has been spread and central tendency. Shows that most content falls within certain runtime range. So while some titles may have very high or low runtimes indicating the presence of outliers, this suggests that while most content follows standard duration patterns, a few titles deviate significantly. And business impact is positive impact, negative impact. So helps in identifying standard content duration preferred by the platform. Extremely long or short may not align with user preference. And the chart 11 shows that which country has the country has produced more movies that are present in Amazon Prime. So we can see that US has most of the contribution of the movies that are present in Amazon EDA. So this pie chart will help us to show the proportion of categories, and this chart helps in understanding how content is distributed across different countries, highlighted regional production trends. So the chart shows that few countries contribute to the majority of the content, like US dominating the production. So will the gain have this positive business impact? Yes, of course. We can just push the movies that is been more produced by the US. Strong content from dominated countries ensures consistent quality and audience familiarity. Negative impacts like over reliance on few regions may limit the global diversity. And chart 11, so we are just identifying chart 12, we are just identifying the movies that are produced between 2000 to 2009, and we can just see that 2008 has a major contribution, 2009. That means the larger the year coming, the more the recent movies are being establishing. So that is our insights from this. So he tells us to peak production year like 2000, useful for analyzing historical growth, trends, movies in the movies industries. And chart 13, I'm just extracting the movies that has been produced between 2010 and 19. Here also, as the movies, as the years are increasing, the portions are also increasing. So identifies the growth phase of the industry, helps us to understand which years had higher content availability. Negative impact, uneven distribution may indicate dependency on certain peak years. Then chart 14 has 2022, 2025, and even from this also we can see that there were no movies from 23 to 25 as well. So used to show the proportion of movies produced each year in the recent period, helps to analyze the current trends. So this chart shows even recent production patterns. Some years may show drop or spike into the movie production extent, factors influencing production. And we do have a positive impact, helps us to identify recent trends and recovery or growth in production, useful for predicting future content supply. Negative impact, sudden drops in certain years may indicate disruption in the production. So chart 15, it is a correlation heat map. Generally it is a multivariate. We are going to identify the relation between each variable to the respective variable. Here we can see that if it is 0, it is no relation. If it is 1, positive 1, there is a positive relation. If it is negative 1, then there is no relation. So each value with that particular value as 1, as we can see in the red. So that means they have a positive relation. So the correlation heat map is used to understand the relationship between numerical variables in dataset. It helps us to identify whether variables are positively or negatively related, which is useful for detecting patterns and dependencies. So IMDb now moderate positive relation, as we can see here, and meaning popular movies tend to have higher ratings. Runtime may have weak or no correlation with ratings. So some variables show title no relationship, indicating independence. So chart 16 is pair plot. So it is mainly used to compare all this combination IMDb score with the odds, score with the runtime, odds with the runtime, and runtime with all these two. We can see that it has been plotted over here. So a pair plot helps us to visualize relationships between multiple numerical variables simultaneously. It shows both scatter plot and even distribution, making it easier to detect trends, cluster, and outliers as well. So a positive trend can be observed between IMDb odds and IMDb score. Presence of outliers in the odds data is not perfectly linear, indicating multiple influencing factors. So solution to the business objective is achieve the business objective, like based on exploratory data analysis we have made. So the solution that we can give for the business people is that focus on highly rated and highly voted content, invest in successful directors and genres, promote high engagement movies, data driven content recommendation, balance quality and popularity, and improve overall content strategy. And high rated and high voted content, investing in successful creators and genres, promoting engaging movies, and using data driven recommendation, the client can significantly improve content strategy. So EDA of the movies and TV shows dataset provided meaningful insights into content generation, audience engagement, and overall platform performance. So the insights which is derived from this analysis can help in improve content recommendation system, optimize content strategy, and enhance user engagement. By leveraging data driven decision making, the platform can better align its offerings with user preference and makes trends, ultimately leading to improved business performance and customer satisfaction. Thank you. This is the end of our analysis. Thank you.